Hi all. In this session, we'll be looking at the second part of ratios where we are trying to understand how do I calculate actual values from ratios. Okay. Now, let's look at this first simple statement. If the ratio of the amounts with A and B is 2:3, find the amounts with them. Now, one common mistake that students generally commit here is, they start writing that A has 2 rupees and B has 3 rupees. Now, please understand, this would be completely wrong. They might have 2 and 3, but I'm not very sure if they have 2 and 3, because coming from the previous session, we have realized that we come down to a ratio after cancelling all the common terms. Let's take a few examples. Suppose A has 20 rupees and B has 30 rupees. Right now, what is the ratio of them? If I calculate the ratio of them, I would write A has 2 into 10 and B has 3 into 10. Now this 10 is getting cancelled and then I am getting the ratio as 2:3. So please remember, when I say 2:3, 2 and 3 need not be the only values. I can have 20 and 30 also, because after cancelling a common term, I get the ratio called 2:3. Now will it be 20 and 30? It can be any value in this ratio. Suppose, let's take one more example where I'm talking about, let's say I have 30 with A and B has 45. Now what is 30? 30 is 15 into 2, and what is 45? 45 is 15 into 3. Now what do I see? I can cancel 15 and 15 on both the sides, and finally my ratio is 2:3. So we can see that A and B can have 20 and 30. Even in that case, the ratio is 2:3. A and B can have 30 and 45. Even in that case, the ratio is 2:3. So which means it's pretty clear that if the ratio is 2 and 3, 2:3, 2 and 3 might not be the only values with A and B. Right? So how do I convert them into actual value? We see that there's a common term that is cancelled in both the terms. Here also the same term is cancelled in both the terms. So always remember, whenever you have a ratio value given, to convert into actual value, multiply with the same term to both the terms or 3 terms or 4 terms, whatever number of terms is given in the same ratio. So if I have 2:3, let's say I use an alphabet called K, so I can assume that 2 into K is an actual amount with A, as well as 3 into K would be the actual amount with B. So I cannot say that 2 and 3 are the values, because the question has to give me some other information to go ahead and calculate the value of K and determine the actual amounts with A and B. So the conclusion of this slide is, only with the help of ratio I cannot calculate anything. Only thing I can say is A has 2k rupees, then B has 3k rupees. It can be any alphabet of English. Here I can have A as 2x, similarly B will have 3x, or we will have A as 2y, then B will have 3y, and so on and so on and so on. But the same alphabet has to be, or same variable has to be multiplied to all the terms of the same ratio. Clear? So just to extend this here itself, instead of 2 terms, what if I would have given you a ratio of 3 terms? Let's see. So if I'm given ratio of 3 terms, if I'm given ratio of 3 terms, suppose the amounts with A is to B is to C is 2:3 is to 4. Now all I can conclude again is 3 of them are in the same ratio. I have to multiply the same variable with all the 3 of them. I would say this is, let's say 2x, this is 3x, and this is 4x. Or I can say this is 2a, this is 3a, or this is 4a, and this becomes the final actual amounts of the ratio. Please remember, the question has to give us some other information to go forward, determine the value of A, and then get our final answers. Let's move to the next slide. Now, what if I'm given 2 different ratios? Now, this is also very commonly mistaken, an error-prone area where students commit mistakes here. Okay. Now, if the ratio of number of students of boys and girls in class A, let me talk about class A. Class A, boys is to girls given to me is 3:4. Now, what do students do? They write 3k and let's say they write 4k. Or let us use a term called x here. So I might assume 3x and 4x. Is this correct? Perfectly correct. Now let's talk about class B. In class B, the ratio of boys and girls given to me is 2:3. Now what students do is, students write 2x and 3x here as well. Now this is completely wrong. Now why is it wrong? Because these are two different ratios. X need not be same in both the cases. Clear? So I can take a few examples. Let's say I'm taking 30 students in class, boys of class A and 40 students in girls of class B. Clear? Having said that, I can take, let's say 30 students as boys of class B and 45 students as girls of class B. Now let's see. Here what is cancelled? I get 10 into 3, 10 into 4. So what am I cancelling? I'm cancelling 10. And therefore I get the final ratio as 3:4. Let's assume 10 is equal to x. Now in this is 15 into 2 and this is 15 into 3. Now what am I cancelling? I'm cancelling 15 here, but x we had taken as 10. Right, now this is what I want you to understand, that if there are two different ratios, the variable definitely cannot be assumed as same. They might end up same, but our job is to assume different variables because there is a possibility of having a different answer. So how do I solve this question? If I am given this question, the best possible method of solving this question would be is, if the variable of class A I am assuming as x, my job is to assume a different variable. So let's say I use that the class B has 2y and 3y. So please remember, if I have two ratios in the same question, the variables have to be different. Let's take one more example. Suppose I'm saying in class A, the ratio of boys and girls is 3:4, and in class B, the ratio of boys and girls is also 3:4. Now how do I treat with it? The treatment will be same. These are two different ratios in the same question. So my duty would be is, I would take 3x and 4x as the boys and girls of class A, and I would take 3y and 4y as boys and girls of class B, and then continue with our question or the information given in the question. So to summarize, if I'm given only ratio, I cannot calculate the actual amounts. Point number one. Point number two, if I am given ratio, to convert into actual terms, I have to multiply every term of the ratio with the same variable. Point number three, if I am given two ratios in the same question, the variables that we are using have to be different. Now let's start applying them. Now I'm given divide 108 into two parts in the ratio of 4:5. When ratio is given as 4:5, I would, let's say, assume 4x and 5x as their values. Now what am I also given? I'm given 4x plus 5x is equal to 108. So what do I get from here? I get 9x is equal to 108, or the value of x that gets is equal to 9 into 12 is 108. So the value of x is equal to 12. If the value of x is equal to 12, I want to find the number. So one number is 4x. So one value becomes 4 into 12, that is 48. And the second number becomes 5x. That becomes 5 into 12, that's going to be 60. So 48 and 60 are going to be the two values of the numbers which are asked in the question. This is the basic method of solving it. Okay. Now, what is the other way? Now I always recommend this when total is given. Okay. So it's like this. I'm dividing a total of 108 into two parts. That is 4:5. Now remember, this value of this part, fourth part, would be 4 divided by, add all the terms given. The terms given to me is 4 plus 5 multiplied by the total quantity. Now the total quantity is 108. Whenever total is given, always follow this method to save your time in the examination, right? So this is 9 ones and 9 12s. So I directly get the value of this is going to be 48. Let's apply this. Now this is going to be 5 divided by 4 plus 5 of total. Now the total is 108 again. Clear? So this is 9 ones and 9 12s, 5 12s are 60 becomes our final value. So 48 and 60, 48 plus 60 is 108, and that's going to be our final answer. Let's look at one more example. Two methods. I'm dividing the whole board into two parts. One is a basic method. What is a basic method? I am given divide 1500 in the ratio of 3:5:2. So I can say this as 3x, 5x and 2x. So this plus this is equal to 1500. So 3 plus 5 is 8, 8 plus 2 is 10. If 10x is equal to 1500, so what do I get from here? If 10x is equal to 1500, the value of x is equal to 150. If the value of x is equal to 150, now what is the value of this part? That's going to be 3 into 150, which is going to be 450. The value of the second part becomes 5x, that is 5 into 150, that is 750. And the value of third part is 2x, that is 2 into 150, that is 300. And these become the values of them. Now, as I told you, when total is given, we can use a different method. So what do I do? The first part is 3 divided by, I add all the 3 of them. 3 plus 5 plus 2 into 1500. So this is 10 and a 0 gets cancelled. So 3 into 150. So the first part becomes 450. What is the second part? That's 5 divided by 3 plus 5 plus 2 into 1500. Again 10 and a 0 gets cancelled. So 5 into 150 will give me 750. And the third part is going to be 2 divided by 10 into 1500. And this will finally give us 300 because the 0 and 0 will get cancelled. So this is how I solve ratios when I'm given basic values. There is one more simplified way of calculating ratios. We'll discuss that in the coming slides. Now, the ratio of copper and zinc given to me is 5:3. Whenever ratio is given, first point, convert into actual value. So I would say that the actual quantity of copper is 5x, maybe grams or kilograms. And the actual quantity of zinc would be 3x grams or kilograms. Now, the question says if the weight of copper in the alloy is 30 grams, which means the question says if 5x is equal to 30. If 5x is equal to 30, 5 ones are 5 six are. So we get the value of x is equal to 6. If x is equal to 6, 3 into 6, my final value becomes 18 is the quantity of zinc. Sometimes the question might ask you find the total quantity of copper. So there 30 plus 18 is equal to 48 is one way of solving it. Clear? Or there's a different way of solving ratios as well. Let's try to understand. The other way of solving ratio is, I know that this is 5 parts and this is 3 parts. Let's write 5 parts and 3 parts. And the total is 8 parts. So this is total, this is zinc and this is copper. Now, as per the question, I'm given that copper is 30 grams. When copper is 30 grams, we know that whenever I'm given a ratio to convert into actual value, each term is multiplied with a common multiplying factor. So 5 into what will give me 30? 5 into 6 will give me 30. If I'm given 5 into 6 as 30, that means the same multiplying factor applies to all of them. So 3 into 6, if the question is asking me zinc, I calculate 18. Suppose the question has not asked me zinc and the question is asking me total. So that I can directly calculate if the multiplying factor is 6, even here I get 8 into 6, which means 48 is the total weight of the complete alloy. So this method helps us to eliminate calculating zinc for the total. So if zinc is asked, I can use this directly. If total is asked, I can directly calculate from the first part to the third part. Right? So this method is very helpful when it comes to, appearing exams or solving questions in the aptitude examinations. Let's look at one more question. Now this question says that the ratio of ages of A, B and C is 7:5:4. And C's age is 32 years. Let's apply the previous question's method. So A given to me is 7 parts, B given to me is 5 parts, and C given to me is 4 parts. As per the question, this is equal to 32. So what is the multiplying factor? The multiplying factor is 8. Now let's look at the question individually. What is that we are calculating? We have to calculate A's age. Can I directly calculate A's age? Of course, yes. What is A's age? The multiplying factor remains the same. So 7 into 8, the age of A will be 56. Clear? Now, the sum of their ages. If I'm looking at second question alone, I do not have this information. Neither do I need to calculate it. Now the question is asking you sum of their ages. Till when I'm playing with the same ratio, the multiplying factor is applicable. So the question is asking me A plus B plus C. Let's add the parts. 7 plus 5 is 12. 12 plus 4 is 16. So if I'm coming with the same ratio, the multiplying factor remains the same. 8 6 are 48. 8 I carry 4. 8 1s are 8. 8 plus 4 is 12. So 128 becomes the sum of their ages. Clear? Now let's look at the third question. The third question says the difference between the ages of A and C. So I'm solving that here. So I am calculating A minus C. What is A minus C here? 7 minus 4, that is 3. Again, this 3 is derived from the same ratio. When I'm deriving from the same ratio, I can use the same multiplying factor. So the difference between the ages of A and C would be 24. I can directly get it instead of calculating the value of A and then further subtracting. Clear? So this becomes a very simplified approach of solving it, which was an advanced method continuing from the previous slide. Now if I want to go with the basic method, I can as well do it. The basic method says A is equal to 7x, B is equal to 5x, C is equal to 4x. Let's write what is asked also, sum of their ages. So I am asked 7x here, we'll calculate it. Sum of their ages will be 7 plus 5 plus 4, that is 16x here. And difference of A and C is 3x here. This is what is asked. Clear? So now, if I have C's age as 32, which means if 4x is equal to 32, what do I get? I get the value of x is equal to 8. Clear? If x is equal to 8, I can get all the three answers. I get 7 into 8, that is equal to 56. I get 16 into 8, that is equal to 128. And I get 3 into 8, that is equal to 24. So this is also a basic method of solving these questions. So that's it from this video, where we learned how to convert ratios into actual value, multiplying the same, every term of the same ratio with the same variable. And we also saw a simplified shortcut. If I'm using the same terms from the same ratio, the multiplying factor remains the same. So there are two basic methods. You take 5x, 6x and solve it, or you take 5 parts as 30 and move forward. Let's practice these questions, and then in the next video, we will go ahead with applications of the same. Thank you guys.